So students, once again welcome back. So now we are starting next set of question for JEE Advanced Pattern Physics course. Well, in this particular question and discussion video, we are starting with this integer type question, but you can say there is a combination of various type of questions, more than one correct, maybe like one only, one correct, matrix match and so on. And these questions are mainly based upon, you can say, collisions, some questions based upon, you can say, basic concepts of rotational motion, like that. But I am not telling you that this question is from that segment. I am not telling. It is, reason is, when the question you are supposed to face in examination hall, is it like that it is mentioned before the question, this question is from this topic, this class, this? No, not like that. So why should go in those details which are meaningless? Read the question, think upon the merit demerits of the question, try to find the solution, that is it, fine. So here it is one question. A ball moving at 60 degree with vertical. With vertical means this is vertical line, ball is moving like this, fine, angle is from vertical, collides with a smooth horizontal surface perfectly inelastically. Inelastic collision means what? Momentum will remain conserved, but kinetic energy loss will take place. If kinetic energy of the ball before the collision is 12 joule, okay, kinetic energy of the ball after the collision is x joule, find the value of x. Obviously loss will take place. So x is definitely less than 12, fine. So let us try to find out the solution, because it is inelastic collision because of that reason. So over here, what exactly, I think I should draw the diagram first, a simple diagram, that is, sorry, this way, fine, like this, like this, this is 60 degree and this is 90 minus theta. Theta is equal to 60 degree, it is given. So obviously it is going to be 30 degree, fine. So this value is, let us say this is u. So this is going to be u cos theta and this is going to be u sin theta, fine. So u sin theta and well, I think I should use the diagram. I should draw a big diagram here in the question itself, fine. Like this, y axis, x axis, u, it is 60, it is 30, put the values directly. So it is going to be u cos 30, that is root 3 by 2 u. It is u sin 30, you have to consider the angle from this. You can consider like this, then the value sin will change in cos, cos will change in sin, and it is going to be that is u sin 30, so it will be u by 2. That is vertical component and this is horizontal component. Now horizontal component, as you know, remains same, and vertical component at the highest point is going to be 0. Half mu square is equal to 12 joule. It is given. Well, over here what I should say, if the collision is inelastic, then if collision, I think I should not use word if, it is given, so why I should say if, as collision is perfectly inelastic, perfectly See, you need not to do all these steps in examination hall. Here I am doing it just to give you the understanding. So, please understand it. As collision is perfectly inelastic, fine. As collision is perfectly inelastic, therefore, component of velocity u by 2 means this is the component of velocity u by 2 will finally 0. Now, this is something just to explain you so that you can get the proper understanding. That is why I mentioned this these 2-3 lines, fine. Now, from here next line is component root 3 by 2 u, root 3 by 2 u remains unchanged. Fine. So, now first is kinetic energy, this much given. Collision is perfectly inelastic, component of velocity u, that is u by 2 will finally 0, and component of u, velocity u, root 3 by 2 which is horizontal component, that is u, it will remains unchanged, fine. So, what I should say? I should say u y 0 u x same, fine. Now, after this if I want to find the kinetic energy, then which velocity I should use? You may simply say, sir, you do not have any option, you have to use this velocity because finally it is 0, fine. So, the kinetic energy is due to u x component, okay. So, this implies that Ke is equal to half m, okay, ux square, and the value of ux square is 3 by 2 u whole square, fine. Now, put the values. So, what you will get? You will get it as 1 by 2 m 3 by 4 u square, clear? Yes. So, it is 3 by 8 m u, sorry, I think I should do the makeup in a different way. I will write it as 3 by 4 and within bracket 1 by 2 mu square, more easy to visualize. But try to recall, half mu square is equal to 12 joule, it is given. So, this entire bracket will be replaced by 12, okay. So, just take a look over here, I need some space, I think I should use this place also. It will be kinetic energy is equal to 3 by 4 1 by 2 m u square and 3 by 4 into 12. Why? Because half mu square is equal to 12 joule, initially it is given. 3, so it will be 9 joule. Fine. So kinetic energy now, I think I should mention it as prime, that is 9 joule, and compare it this with x joule. So you can say that x is equal to 9. This is your answer. Fine. So the question was anyway not a difficult one. Visualization was somehow required, and we used the idea of this conservation of energy. Fine. My suggestion to all of you about this question is, please try to solve this problem also from the point of view of let us say collision is perfectly elastic. Think on that. Why I am saying so? Because according to the confusion, you will definitely get confused that when the particle will reach at its highest point, so this uy component is going to be 0. Then what will happen? So in one problem you can think this way, that way, upside, downside. Also you can visualize some other aspects. So this way, by this way, if you visualize, it will definitely enhance your capabilities of tackling the problem more efficiently. Fine. And these are questions which will definitely give you some basic idea of how you should tackle these type of questions, basically from matrix match, or you can say integer type. When I was preparing for JEE, it was some like 2000 or so. At that point of time, they used to also ask fill in the blanks. Fine. So fill in the blanks and integer type somehow similar. Now from here I should go for this next question, which is going to be question number 2. Now over here only one option is correct in this particular question. Fine. Now what exactly is required over here? The particles of equal mass m at A and B are connected by a rigid light rod. It is like this way. I have this rigid rod. Okay. There are 2 points A and B. 2 particles of same mass m and m are attached, fixed like this. The particles of equal mass m at A and B are connected by a rigid light rod AB. Clear? I will draw the diagram also. Lying on a smooth horizontal table. It is like that. It is lying on this smooth surface. Fine. One particle here, I think I should show you, that way visualization is more easy. One, another. Fine. See, in physics sometimes you will laugh, this is the problem. Problem is, if you are unable to visualize the problem, then the problem is going to create so many problems. Fine. So first thing is you should visualize. An impulse J is applied at A in the plane of the table by means of hitting one mass or somehow like that table and perpendicular to AB. So if the rod is like this, something is hitting like this. Fine. Then velocity of the particle at A. Actually you have to find the value of the velocity of the particle at which this impulse is applied. Fine. So I hope you have visualized the problem, but somehow if some confusion is there, A, B, fine, L, L. Let us say this is the total length. So it will move like this. That is why I am showing you the direction. Fine. you have to find the velocity of the particle at A, this particle velocity. In traditional problems, you may also have been answered like this, how it will move, and somehow like other related concepts. Well, assumption is that it starts rotating about its center of mass, somehow like this. So, let us try to put the values. Fine. I am going to write down our formula, but before that please take a look of the problem. Fine. Now, I am writing a formula, that is V is equal to J by 2m, where J is impulse. If any student has any difficulty with this relation number 1, please go through with basics. Yes, I know, if any student has some difficulty with this basic relation, please go through with the basics of class 11th of this chapter, but I hope you all are going to be comfortable. Now, this is linear velocity. Fine. We want to talk in terms of the angular velocity. So, omega, which I am showing you over here, is going to be how much? J into I upon 2 ml square. Moment of inertia and this term. Fine. So, what I can say over here now, this J value is somehow we can change it. So, finally, I can write it as J by 2 ml. Fine. So, J by 2 ml, and from here I can say velocity of A is equal to V plus I omega. Fine. So, I think I should write it down in this manner. Va is equal to V plus I omega, and it will give me J by 2m plus J by 2m. Yes, fine, because this value from here and this is something J by 2m I by L. Yes. So, what you will get from here? You will get V A is equal to 2j upon 2m, that is J by 2m. Fine. So, no 2 is going to be cancelled, 2 is going to be cancelled. It is 2 into 2, so 2 is going to be cancelled. This implies that V A is equal to J by m. Yeah, that is fine. Fine. So, just take a look of this relation J by m, J by m. So, B is the correct option from here. So, I will say only one option correct. So, V is the correct option for this particular question. Let me allow to write it down. Only one option correct. Very fundamental question. Fine. Then comes question number 3. More than one option correct. This is the instruction for this question number 3. More than one option is correct. It is not like that always more than one option correct. Possibilities, because in general the tendency of the students, moment they notice more than one option is correct, perfectly, it means more than one is correct. Why you are taking the pain for this thing? Solve it properly and then mark all correct options which you concluded. Let us say you find out A and C is the correct option and you are not finding any other option, only mark A and C. Move. If D is there, no problem, some small amount of marks will be deducted. But if you mark a incorrect option, that is going to be horrible. Fine. Now, read the question. A particle of mass m is travelling with a constant velocity v is equal to v naught I. It means particle is moving along x axis. Along the line y is equal to b and z is equal to 0. Y is equal to b and z is equal to 0. Okay, close your eyes, visualize. I hope simple for the visualization. Let dA be the area swept out by position vector from origin to the particle in time dt, and L is the magnitude of angular momentum of the particle about origin at any time t. It is not any, fine, it is any, n is here, a is here, like that, at any time t. Then you have to find out which one is the correct option. Let me read the question once again. Particle travelling with constant velocity along x axis, and along the line y is equal to b and z is equal to 0. So, y is equal to b means b is constant, this distance. Let dA be the area swept out by the position vector from origin to the particle in time dt, and L is angular momentum. Then you have to find out which option given over here is correct. One option, or rather two options are associated with angular momentum L, and two options are associated with area swept out by the line joining the particle to the origin. Now, angular momentum L is equal to I am not drawing the diagram because it is so simple. Now, from here also I can say L is equal to from the problem it is m v naught b, it is constant. Fine, it is given in the problem, it is constant. Now, mod of position vector r1, we assume that position vector. So, mod of position vector r1 r2, fine. This is the general expression, this is given. This is something that we visualize. Now, from here I will say area swept out is equal to area swept out dA is equal to 1 by 2 v naught dt, half v naught dt r sin theta. Now, many of you will say, sir, we are unable to understand from where you are getting this relation. This is something which is constant. So, dA by dt, and then you have to calculate the value half v naught dt r sin theta. So, from here what I should do, I should rub this portion So, from here I can say dA by dt, dA by dt is equal to 1 by 2 is going to be same 1 by 2, and what exactly it is 1 by m, 1 by 2 into 1 by n, and then this value, that is m v naught r sin theta, correct? Yes. You can cancel it? No, there is no point of cancelling it. Why to cancel? ultimately we have to find, okay, there is no point of solving further. M L. So what I can say from here, dA by dt L upon 2m, fine. Yes, L upon 2m. So first L is constant, obviously L is constant, fine. So A is the correct option. I think I should come over here. A is the correct option. Another is your dA by dt, which is going to be how much? It is going to be L upon 2m. So 2L, L upon 2m, D is the correct option. So there are two options correct in this particular question. The question was fundamental, basic, but yes, up to some extent some visualization was required. And yes, up to some extent you can say that these type of questions are there just to check. It is not like that these type of questions will definitely be asked in JEE Advanced exam. But here I am just trying to give you the idea that you should always try your best to remain with close approach of basics, because all problems in JEE Advanced exam, they are mainly associated with basic concept of the subject, fine. Now question number 4 and 5, both questions, they are matrix match type. Matrix match means some statement is given, below that statement there is table 1, table 2, fine, and various items of table 1 should be matched with the other options of table B, like that. So in these type of questions, it may possible that more than one item of table A may of table 1 may match with the more than one items of table B, it is possible. So we should be very careful with these type of questions also. Just consider this question, you may be slightly confused that where is the problem. So because the question and its you can say options are big one, so that is why on one slide I have placed this entire statement or question, and over here it is table 1 and table 2, fine. So first we will read and understand the issue, the problem, the concept, then we will come over here and we will try to solve one by one. A disk with linear velocity v, there is no scope for imagination as such, I provided the entire diagram, and angular velocity omega is placed on rough ground. So it is like that, rotation plus translation, both type of motions taking place. It is like this and simultaneously it is also moving. It is somehow like the motion of the wheel of a bicycle, wheel of a car, wheel of a bike, like that, fine, and it is on the rough ground. Suppose A and alpha be the magnitude of linear and angular acceleration due to friction. Then let us try to understand problem once again. Disk with linear velocity v, angular velocity omega is placed on rough ground. A and alpha, magnitude of linear and angular acceleration due to friction. Then you have to find the answer, or you can say correct statement for 1, 2, 3 statements of table 1 with 4 statements of table 2. Got the idea? So let us try to find the solution one by one. Now there are 3 cases. When V is equal to R omega, case number 1 given, but I am writing because I have to solve it. When V is equal to R omega by 2, when V is equal to 2R omega. And I hope you can visualize this from the center, from top periphery, from the point which is in contact with the rough surface. So, all these three possibilities are mentioned over here. Now, take a look. After that, I am coming into picture. When V is equal to R omega, then force of friction Fs, in general it is represented like this, is equal to 0. Fine. In general it is represented by like this way. So, it is when V is equal to R omega, then force of friction Fs is equal to 0. Fine. Now, when this scenario is there, it means omega, where is that diagram? This one, oh sorry, this one. It means omega and this alpha, fine. So, omega, this implies that omega and alpha both are 0, fine. If this is the scenario, fine. So, what I should say about the first option, that is when V is equal to R omega, then out of these options none is matching, fine. So, I think I should mention over here A S, nothing is given like this. This is case number 1. Second case, when V is equal to R omega by 2. Take a look of the diagram once again, fine, this way. So, V is equal to R omega by 2, and in this scenario, at this point, back slipping will take place, fine. At this point back slipping will take place. So, Fs, that is frictional force, Fs is maximum, fine, and in forward direction, fine, and in forward direction. So, what I can say, then I can say that A is equal to, now please take a look, because Fs is maximum. So, I will say mu mg by m, mu mg by m or mu g. See, matrix match, integer type, these questions need, you can say, proper explanation, only then you can conclude the correct options. So, if this is the scenario, then I can say alpha is equal to twice mu g by r, fine. So, from here this way you can say that alpha is equal to 2 mu g by r. So, for B option R is the correct option, it is less than, obviously it is less than, yes, acceleration is less than. So, B is what? B is R option, correct, fine. Similarly, you can go for the next set of situation, that is when alpha is V is equal to 2 r omega, and in this scenario I think I should just give you the basic idea. So r alpha is equal to r alpha is equal to 2 mu c. Yes, r alpha is equal to 2 mu z, or acceleration a should be less than r alpha. So you can say that this way c is going to be r once again. So c is again going to be r, this one. Obviously, matrix match type of questions are slightly long sometimes, and you have to match with the given process of the problem. Fine, over here. Then comes question number 5, and question number 5 is it was small, so now I placed it on a one simple single slide. If radius of earth is reduced to half without changing its mass, it's a very, you can say, loved one question by the students, by the teachers simultaneously. There is no scope as such for me to explain a lot, because I do not want to waste your time. I just give you the basic idea, because I am sure all of you can solve this problem very properly. Fine, a well known problem. Anyway, suddenly reduced to half without changing its mass. So moment of inertia will definitely change, time period will definitely change. So over here it is mentioned like this: angular momentum of the earth obviously will remain constant, conservation of angular momentum, time period of rotation of the earth 1/6 rotational kinetic energy. So this way you have to find out some simple concept. Let me allow to write down 1 or 2 steps. Fine. So A is angular momentum of the earth, it will remain same, because I1 omega 1 is equal to I2 omega 2 is applicable. Fine. Now from here I can say I is directly proportional to r square, mr square, 4 by 3, fine. So it is 2 by 3, 2 by 5, like that, depending upon the solid sphere, hollow sphere, and so on so forth. So you can find that time period of rotation of the earth will become 2 times, will become 4 times, will become basically 1/6. It is 6 hours, fine. So will become 4 times, no, will become 1/4 times. So as such, for B, no option is correct. S, rotational kinetic energy of the earth, fine. Rotational kinetic energy is L square upon 2I, okay. So L square upon 2I, so it is going to be 4 times. So rotational kinetic energy is Q. Very fundamental question in a very fundamental touch. So students, this was slightly a long discussion of these only 5 questions, but I can't help it out, it is like that. Few questions were long, few questions were simple. I hope you will enjoy the watching of this video. Soon I will come back. Till then, take care of yourself. Have a nice time.